Hey, welcome back to the bench. Good to see you again. Thanks for joining the channel. Today on the bench I have a Citation 15 tuner. Now I have a stack of tuners and I've been meaning to get to them, but I've been holding off because I don't have my stereo encoder yet built. I was going to build one and it still hasn't happened. Just haven't had time. But I still want to get moving on some of these. So I think we're going to do a video on the 15 today and we'll have a look at this. It's been sitting around a long time waiting for the bench, but today it's going to have its day. So let's have a look at it. If any of you are familiar with it, you'll know all about this. So on the left hand side here we have a bunch of controls. This is a pilot lamp, a power button, chunk, and here is our external Dolby noise reduction. Now I think this is like an external loop that you can put in or take out, and if you want to connect up an external Dolby noise reduction box, you can do that with this switch. Level set tone, I'm not really sure. I think it provides an internal tone from a tone generator. Mute button, I think this is a global mute, not just a mute interstation mute. I'm not sure about that. I'm not 100% sure yet. We're going to find out. A tape out jack, 1/4 inch stereo I'm assuming, and this is outputting a signal for your tape deck. And then we have two variable gain controls, left and right channel, independent of each other. On the right hand side here we have stereo automatic button when it's out, and pressing it in it creates a mono signal. It's great for weak stations. Stereo noise filter. I don't know exactly what this does, but typically these stereo noise filters is a capacitor that goes between the left and right channel, and what that does is it kind of shunts the high frequencies to each channel, so it kind of creates a mono image of the high frequencies. I'm talking maybe 5 kilohertz and up, and what that does is it gets rid of it gets rid of your stereo separation at high frequencies, but it also gets rid of a lot of noise. It's a compromise thing. So I don't know for sure. I'm going to look into that too. I shouldn't be talking about this stuff, but should have done my research, but we're just going to wing it. And then we have a large tuning control. So when you turn it on, you don't have a dial scale, traditional dial scale. You have this tumbler thing that rotates, and it's driven with a dial string. And then here we have, if I turn the lights off you can see it a lot better. We have 2 meters. One's a quieting meter and one's a center tuning meter. And as of right now I don't see a needle in this one. That's really odd. Unless it's pegged one side or the other or it's broken. I see no needle. This one has a needle, and it is frozen in one position. So it looks like we have some work to do. Quick look at the back panel. We got a lot going on here. We got a power coming in, fuse 1.5 amps, and then we have a courtesy outlet switched. Now we have an output to a quad decoder. This will be picked off as the FM signal is decoded, and this will have all the information in it. I don't think anything's stripped off, so I don't know. Quad decoders, they were a thing back in the day. I don't think I've ever seen one. That's interesting. That's interesting, isn't it? But it was an upgrade option. We have inputs. We have 75 ohm, 300 ohm, stereo threshold, and a muting threshold. So these are adjustable at the back, and these will set your muting level. Here's our Dolby noise reduction loop coming out and going back in. So you connect your device between these 4. And 2 sets of outputs, a variable output and a fixed output. Okay, so ready to turn it on. I got the amp going. Let's turn this down so we don't blast you. And we're getting a bit of a hum. And let me adjust the muting on the back. I think we have a non-functioning tuner here. Yeah, there's nothing happening. Completely dead, except for some power supply hum. Some nasty growls. It's not happy. So, completely... Oh, what was that? So, we got a non-functioning tuner. So, probably a lot of things going on inside. So, let's get it started. Alright, it's unplugged. The screws are out. Let's have the big reveal. Nice clean lid on the inside. And what do we have? Yes, I remember this, modular boards. So I got a couple of modules here. These plug in. Yeah, it looks very nice condition. Very clean inside. It's very clean because there's no ventilation on this tuner. So let me get the bottom off as well, and then we'll start troubleshooting. I think probably may have a problem in the power supply. I don't know. We have an unobtainium chip here. It's from Motorola. I don't know what that chip is. Alright, bottom's open. You can see this chassis design. Got two boards down here. This one obviously looks like power supply. And this one looks like a stereo amplifier, because it's got two of the same circuits here. So I'm assuming it's a stereo audio amp. Line output amplifier. And we have the bottom of our tuning block. Our filter cap. AC mains is over here, and we do have wires running up to this power switch, which is covered. It's our AC switch, so we got to be careful of everything back here in this corner when we're servicing. Nice build quality, very nice build quality, but I don't know what the problem is here, so we're gonna have to start figuring it out. Let me get the manual out and we'll see if we can get our voltages on our power supply. That would be our first step. Okay, not a very good scan here, but I'm going to show you a few things. So here's a transformer. We've got three secondary windings. One of them is dedicated for pilot lights. Okay, this one here and this one here comprise two separate supplies. This one here goes through rectification, and it goes to the three capacitor can, and that should be our plus 50 volts. So we should get 50 volts on the output of this can. And then the other supply, let's see here. Yeah, they're using this capacitor as well, and this supply. And then this supply goes through a 27 ohm 3 watt resistor, 802, R802. And then goes into this transistor. So we should have 34 volts here. Goes into the transistor. Coming out of the transistor, we should have plus 15. Alright, so we're going to have to check for that voltage. And then this one here, output level. This has got a blocking capacitor here, so I don't know what they're doing with this. Power supply, oh, this is that oscillator. That local oscillator. Well, all of these three transistors here. This here is regulated power supply, this is local oscillator. So I see what they're doing here. So, feedback, output level, how do we, I guess it's running all the time. So we should have a signal on this all the time, because it's fed with 15 volts. Alright, pretty simple. So we look for 15 volts on the emitter of Q801. And we'll look for plus 50 volts on this capacitor, and negative 15 volts. So here we go. Here's another supply, negative 15 volts, and that is C808. So we'll see if we have those voltages. Alright, plugged in, turning on. We're live. So let's check this capacitor here. Let's see what we got. 0. Is that AC on there? Can't be AC. This pin here, 64.4 volts. 50 volts. That looks right. Now this one here, 34 volts. Okay, so that should be this here, 34 volts. No, we got 29. What about the emitter? Should we have 15? Yes. Now where's our negative 15? Negative 17 almost. 15, 34, okay, I'm consuming 26 watts. 26 watts of doing nothing. I think the power supplies are okay except for that negative, which was it? Negative, let's see which one it was again. Yeah, the negative 15 volt supply is high. It's almost 17 volts. Here's a look at what's coming out of the tone oscillator on the power supply board. Switch power on. You see we get nothing. Top trace, there's nothing there. It's flat lining. So we got multiple problems here. Okay, what you're looking at here is the output of the 2 audio amplifiers before it heads out the back panel. And if I click switches, you see we're getting signal going through this amplifier. So those amplifiers are working. I don't know if they're the same amp. It looks like one's got more gain than the other. But that part's working. You have a problem before these amplifiers. Okay, so this is coming off the tuner block, coming into the IF board. I'm picking off the collector of Q301. And we should have some kind of signal here. We turn on the power, it looks flatlining. I don't see anything here at all. If I tune a little bit, I get nothing. Oh, hang on, what's going on? Here's a signal. Do we get a bad tuning capacitor? Maybe that's what our problem is. Okay, so maybe that's what our problem was. So we do have a signal here. Looks like we might have a shorted. I'm manipulating the tuning dial, and it looks like we might have a shorted capacitor. So let me take the lid off that cap, and we'll have a look at it. Okay, power's off. Let's see if we can get this lid off here. Is it just snapped on, or is it soldered in place? Yeah, it's soldered in place in the corners. Right here and here. I'm just going to break the solder joints without desoldering. Just like that. And then we can solder it back when we have when we're putting the lid on, we can just solder it. Come on. There we go. Alright. Screwdriver. What's holding this? There, that is a latch. And there's our tuning capacitor. So for whatever reason, I don't know if we have a short here or not. Let's check with continuity. But that might not work because we might have a coil on there. We would be able to tell. So let's see what we have here. Open. Open. Closed. Open. So this one's closed. Yeah, we have a coil. To figure what's going on with this tuner. It might be just dirty. The connections here might be just dirty. Some deoxit will clear that up. Don't know if I've ever shown this before, but this is how you do a deoxit on a tuning cap. So you're using the red stuff, the red juice this time, because it's a metal to metal sliding contact. And you just put it here where the spring, very tiny drop there. one on each side of this copper. And then one at the end here. And then just work it. Where's the... and work it back and forth. Probably about 10 or 20 times. And what that does is it's going to redistribute the oxide around. The sliding contacts are going to get cleaned, and you'll restore the connection. Okay, to start, I think I'm just going to do is start feeding signals through this thing and see how far I can pick signals off before we lose it or find our break in our chain. So this is the front end. I can feed my signal generator. I can feed a signal in here. We have an RF amp. Let me get away from this. Where is it? Right here. Okay. This schematic was so ridiculously shrunk, I couldn't use it for doing the video. So what I did is I screen captured each individual block or board and blew it up. So here it is. So we can actually read what's going on. So signal comes in, goes through a FET RF amp. This is our local oscillator down here. And then I think we have our mixer, and then we have one stage of amplification before it heads out. So, feed a signal in here. I'm going to put a 98 megahertz, and we can adjust the amplitude up and down. And then we'll go out here. Let me see. We'll go onto the IF board. The signal comes in, and I'll pick it off at the collector of this transistor. And we'll see what kind of signal we have here. So, that transistor is right here in the collector. I can just connect my scope. And then I'll get the second camera set up, and then we'll feed a signal and see what we see on... basically what I'm doing is just testing the integrity of this tuning block. Make sure we have signals going through, confirm yes or no. If we don't, we have to figure out what the problem is. Got the scope going, and I'm going to turn power on. You can see we do have a kind of a signal coming through. So let me tune through the band. Yeah, we're picking up stations. See, there's a station there, 90 megahertz. Let me see what else I can pick up here. I know there's a strong station on the high end. There's a strong one. Right here. Okay, I'm looking at IF signal, that's what I'm looking at. Oh, here's a strong one. Okay, that's the strong one I keep talking about on the high end of the band. So let's go to 98 megahertz. And I'm going to turn up the amplitude of my signal generator. Quite a strong signal. Let's see if we can... Oh, there it is. Yeah. So our signals are getting through the front end. Yeah, it's quite a strong signal there. So everything here is working. Let me put the lid on and just confirm that it's going to stay working. I'm glad, because there's some transistors in here that have the epoxy dome tops, and they're notorious for failing. So I'd have to go in here and do some surgery to get those transistors out. I could show you how difficult it would be. Here, just let me reposition the camera and I'll show you. So here's the tuning block. We've got a number of transistors. There's one here under this shield, and it's upside down. You can see two of the legs come out this side, one leg comes out this side. So try and imagine changing that transistor. It would be quite a chore. Here's another one that's upside down. It has three legs, and yeah, that would not be fun. There's another one. So there's 1, 2, 3, and then there's another one back here you can't see. It's upside down, and it's way buried underneath there. Have fun changing those transistors, because one of them was dead. Problem is, you change it, and then you have to go through and retune all this stuff. There's all these There's some coils in here that are factory tuned, I believe. Most of the slugs you can tune after the fact, but yeah, you'd have a lot of fun doing this. Okay, so this is where we're picking off a signal right here in the collector of Q301. So everything up to here is good. So we have this blocks here that's it says filter 301. That is this box here, the 9-pole LC toroidal linear phase IF filter. So they have some T filtering in here, I'm assuming. They're really sharpening up the IF signal with this. This is one sealed unit. I could probably open it up, but we don't need to. So let's go through and confirm that we have signal flowing through these two chips. And then we get up to here, which is, I believe, is our ratio detector. And then our signal is picked off here at the center tap and comes down and goes in to what looks like a differential pair, because we have an offset adjustment for this pair. And this looks like a beginning stages of an amplifier. So we have our signal coming in. This looks like feedback, and then from here we have, looks like a voltage amplification stage. So this here should be our output of this board, because it goes through, we have here, and then it goes through this, which gives the tuning meter a signal strength, and then it goes through a double backed capacitor out. So this would be AC signal, this would be DC signal. So we should have our output on pin 3. But let's go through and check pin 4 and pin 4 on these two chips, make sure our IF is getting through. We might have a dead chip. Okay, so we're turned on and we have our signal flowing through up to this transistor. It's going through this transistor, so let's confirm we have signal. Just going to remove this. And on pin 4 of this amplifier, we should have some kind of a signal. And it's there. So then it should flow through to this chip, pin 4. And it's there as well. It doesn't look amplified though. Maybe it's got limiting, internal limiting. So that's good. And our output should be on pin 3. I think I said pin 3, yes. Pin 3. So let's see if we have a signal at pin 3, which is right here. What do we got? We have nothing at pin 3. And if I turn up the volume on the signal generator, let's turn up the modulation to 100%. Still don't have anything. No signal coming out. Alright, so we got a problem somewhere in this right here. Let's see if we have anything at R134. The base of 302. Okay, let's pick off the base of 302. Where's 302? Base right here. Yeah, we got a signal there. Okay, so if we tune this in, we have our 1000 hertz tone. Here it is. Okay, so let's check. For some reason we got a signal coming in but nothing coming out. Are you bad? Let's see if we have anything at the base of 304. 304 is where? Right here. Can't see very good. Trying to hook it on without shorting anything. Okay. Looks like we're dead there. No signal at 304, the base. So is 302 dead? Let's check on the collector. Oh, we did. We checked on the collector, and it's dead. So something's going on here, and we need to resolve. Okay. Before I go any farther, I want to check the junctions on these 3 transistors. Make sure we have 3 good transistors. So hopefully I can do this without blocking the camera. So the base. So we got a 660 millivolts there. That's good. 651 on the collector. That's good. These 2 are NPNs. This is the long tail pair. Base. Emitter. 685 millivolts. That's good. 680 millivolts or 79. That's also good. Okay, now we have this one. This one's PNP, so reverse the leads. Collector. Got 1.5 volts. That's not good. And we have 1.1 volts. That's also not good. Something is weird with this transistor. Based, reverse the leads. This transistor's fried. Okay, let's pull this one out and see what it says on my other tester. That might be the culprit here, and that would be this transistor here. It's not amplifying, and nothing is going through. Where is it? Oh, it amplifies and comes through here. Alright, got the suspect transistor out. I got my lights are strobing. This is a, you can read that, it says 152.27722. So that's a Harman Kardon part number. Motorola transistors. Probably, well, these 3 here are just doing audio amplification. So for these 2, you could probably substitute a 2SK1845, and this one here is a 2SA992 would probably work just fine. I don't know what gain they have, but at this point, I don't think it really matters much. All they're doing is they're amplifying the very low level signal from the ratio detector, amplifying it and sending it out. So let's have a look and see what this has to say for itself. Can you read that? I hope so. Unknown damaged part. Try that one more time. Yeah, the transistor's pooched. So, yeah, we can substitute in an A992. Let me, give me a little bit of time. I'm going to cross-reference this and see what it comes back as. But we'll definitely slap a 992 in there, A992 in there. Yeah, it has it right here, Q304, 27722. That's what this is, 27722. Similar to a 2N5087. This is a PNP. So whatever that transistor is, it's probably audio low signal audio amplifier transistor. Nothing spectacular about this. So here's the data sheet for the 2N5087. I don't have any 5087s in stock. I have 5088s and 5089s. I don't know what the difference is. It doesn't really matter. It's not that important. But here's what you want to look for when you're substituting a transistor: is these voltages, do they match? You want to match or exceed these voltages with your new device. The collector current is 50 milliamps. So you want to match or exceed this specification with your new device as well. Dissipation, power dissipation is important too if you have, if you're in some later stages of the amplifier circuit. But as far as this goes, I don't think there's going to be much dissipation. So 625 milliwatts. It's a pretty strong transistor for what it's doing. It's not doing much. It's just amplifying a signal. It's got an easy life. And another thing you want to look at is the gain. So minimum of 250, maximum of 800. So somewhere in this range you want your substitute transistor to fall. And your transition frequency is 40 megahertz. So that's plenty good for audio transistors. All right, so here's what I'm going to change it with. We have the 2SA992. Let's see here. The current gain is somewhere between 150 and 500. Typically 500, maximum of 800. That falls within. VCBO is 120 volts, so it far exceeds that. 50 milliamps, same current. Power dissipation is 500 milliwatts. We're not going to get up to half a watt of dissipation. So this is a good substitute. Transition frequency, where is that? I didn't see it on here. Might be on the second page. I didn't print the whole thing out. So I'll put a 992 in, A992, and then we'll power this thing up, see if we can get it back going again. So pinout is different on these. The original is emitter base collector. It's printed right on the transistor. And these ones are emitter collector base. So we need to, emitter collector base, we need to put this in different. So base, just got to rotate it a third of a turn. Base, emitter collector, and then emitter. Come on. Thought I cleaned that hole out. I did. So we are in. Check and make sure that none of the wires are shorted, because this is awfully close together. Just turn this a bit. You can see that. It's in there. So let's solder this up. I was looking at the soldering on this board. It's shocking. I'll show you a few things in a second here. All right. I don't know if you can see this, I'll point it out to you. Some of these joints are not very good. Like this one here. You see that joint? Here's some other ones too. I'll reflow with all these and then clean it up and give it a good inspection so that we're all good. Another thing I'm going to do is a lot of these carbon comp resistors are going to be out of tolerance. So I'm going to go through and measure these, replace them as necessary. It's going to get all new caps. So this is just, let's just get this thing started and get it going for now, and then we'll come back and do the real work after. Alright, so we're plugged in, I got an amplifier connected. Let's test this thing on. There's our signal generator. So we should be picking up all our FM now. In stereo. It's actually working. It's actually working a lot better than I. Okay, awesome. So now we fixed the problem, and it seems to be working pretty good. But we still will give it an alignment. I can see that both meters are moving here. Everything seems to be working good. Alright, so now let's go through, do our recapping and resistor checks and replacing bad resistors. I'll do that I'll go through one board at a time, and I'll bring you in, and if I'll anything to talk about. I did do some spot checking of these caps, and they are super leaky. They are old, from the mid 70s, early 70s, and they have high leakage, so they all have to go. I don't know if it doesn't sound like there's any dead caps here, but they're all working, but they do have a lot of leakage, and we're going to replace these because of the age. Okay, just a couple of notes here before I start on all the boards. I just want to show you a few things I found just from inspecting. So this transistor has a cracked lead. If you can see that. It is completely cracked. And this one too, it looks like it's cracked, but a lot of heat stress here. The resistor looks fine, and then this one here, soldering. Solder bridge here. Good thing we got some solder mask, otherwise we would have a short circuit. Yeah, the soldering on this thing is atrocious. I think they did it was an early wave soldering technique. It's not soldered by hand. So we'll have to clean all this up and inspect all these. A lot of the joints they look kind of iffy, but yeah, they're okay, I guess. And then another thing is, you have to pay attention here. This cap is marked for positive. And if you go to other caps, they are marked for negative. So you got to be aware of that. The board is marked positive. You can see a positive sign down there between the two, and then a positive sign here. So you got the board is marked, but as you pull the caps off, make sure you confirm. Yeah, this is positive. Axial caps will get replaced with radials. Okay, let's go over the work I did. This one got new caps, replaced 2 resistors that were out of tolerance. Excuse me. And pretty much everything else in this was good. This is the multiplex board. Now they say in the manual, don't adjust these. These are factory tuned coils. They're set to a specific value, and the only way to do that is to remove the coil and use it on an LCR bridge, and set the value of these coils. There's a filter network. Cleaned up the back of the board. Not much else to say about this one. This one here is the power supply. Instead of using axial caps, I'm using radial caps. So what I do is I just drill a hole close to where it needs to be, and just pop in a radial cap and have it stand up, instead of having the leads spread out and stuck through the board. I think it makes it a little tidier, I don't know. But these caps are done. Replaced I think just one resistor on this board. So that one's done. Resoldered it. This is the output board, 2 amplifiers. Same thing. I replaced 2 resistors that were whacked out of tolerance, and then all the caps. Cleaned it. This one here is the IF strip. Same thing. New caps. Probably 1, 2, 3, 4, 5, maybe 4 or 5 resistors that were out of tolerance that I found, and replaced those. This cap here is a bipolar cap, and they had two caps back to back, so I just removed the 2 caps and replaced it with the one bipolar, just to simplify it, clean it up. And this one here was the worst of all of them with regards to resistors. I think I replaced about 10 or 12 resistors on this one. Most of them were really drifty and out of tolerance, temperature drifty. So I replaced those. There's only 3 caps in here, but there's a lot of bad resistors, so they all got done. So let's put it all back together, and then we can start with the alignments. Just looking at this filter cap here for the main power supply. It's a can with 3 capacitors inside of the one, and should note that on the can it says that the outer can is floating from the connections. So that's why this tab here is your negative, and then they have a jumper that goes to chassis ground. And then we have 3 capacitors, 1, 2, and 3. So this one here is a 100 microfarad at 100 volts, and it tests out around 140, 150 microfarad, which is about 40-50% overvalue. A lot of leakage here on this one, so I did connect it to my leakage tester, and it's about 600 microamps of leakage, which is pretty high. I think I might eliminate this capacitor and replace it with a 100 microfarad, 100 volt cap, Nichicon. And I can just put this cap on the board here somewhere. It actually goes here, down here, and I could probably just tack that on the cap on the board, drill a couple holes, run my wires, and have it rest on this board. There's really not room for it, but I can make room. That's one thought. The other 2 capacitors, this one here is a 1000 microfarad at 50 volts. This one's 1000 microfarad at 60 volts. And they're both testing fine. And they're both testing low in leakage. I might just leave these 2 alone and replace this one and be done with the power supply on this thing. So this mechanism here, this tuning mechanism, we have this flywheel, and you notice it's got some gear reduction in here, so they don't turn at the same rate. There's a ball bearing gear reduction. It's not gears, it's ball bearing reduction. There's there's coaxial shaft with ball bearings in between, and the outer shaft. You know, when I take it apart and show you how it works, it's a little unique. But this all needs to be disassembled and relubricated because it doesn't have a proper feel. See how sluggish it is, and it really doesn't want to play nice. This thing should, when you flip it, it should zing for a while. If you really want to go across the band, you just give it a fling and it should go right across. Now it's not that difficult to, well, it is kind of difficult to disassemble this and relubricate it. What you have to do is disconnect the dial string. And the dial string in this thing is dead simple. You have a drum here, and you have a drum on this side on the tuning capacitor, and dial string between it. So you could disconnect. You can disconnect the dial string on one end, unthread it, take this all apart, clean and relubricate it, put it all back together, and then put the dial string on, no problem. And it's not that difficult. I think that's what I'm going to get busy on right now. Now if you want, you can take pictures of all this. This one here has a spring. So this is not the end. You have to go to this side. The end is on this one, right here and right here. These are the ends. So you want to disconnect one of these ends, take the string off, and then take pictures of everything if you're unsure, just so that you don't mess it up. And then there is a diagram in the service manual on how to string this, so it's not really that difficult. And just for reference, the 0 mark should be in the center when it's at this end of the dial scale. That should be your 0 mark, that's your reference. And then if you go to the other side, it goes past 10. So if you do move it a bit, it's one way or the other, it's not a big deal. You're gonna be tweaking for it when you do your alignment anyways. You're gonna be adjusting the inductors and the capacitors to get the dial scale back on track. So it's just better to keep this in line so that it's not that far out of alignment when the time comes to do the alignment. So once you get it apart, you can see this mechanism. This is the ball bearing reduction, and it's a shaft in the inside. It's surrounded by 4, I think, ball bearings, and then the ball bearings roll around on the outside collar, and that grease inside there gets all sticky and sluggish. That's what I'm talking about. You need to remove, take this apart. Well, you don't have to take it apart. You get this piece out and then flush it with some solvents and then put some fresh grease in there, and it restores a lot of the the feel that it should have. So here's the reduction unit. I don't know what the ratio is, doesn't really matter, but I've flushed this out several times with solvent. This stuff here will remove all great traces of grease and oil, and flushed it out about 3-4 times, and it's pretty much dry now. So you're squeaking. I'm just going to give it an injection of grease right in the center where the ball bearings are. I'm going to put a good gob of grease inside on a few spots. Well, I'll just put it on all 4 spots. And then work it, and then you'll start to feel it get a lot smoother. Give it one more here. And that's basically all you do to service this, and it's feels a lot better. This part here rides on this plastic bushing, right? So when you reassemble that, put some grease on that. There's an open bearing here. This one feels pretty good, but I would probably clean it and relubricate it anyway, just so that, because it's starting to 450 grams. So when you reassemble, you should get that kind of action. Low drag. So this drum here, you can see the cracks in the plastic. It's fairly normal. If it gets really bad, you might have to get some epoxy out and wrap this with some floss and put it all back together. I don't know. There's really no stress on this plastic. It just spins in midair. So this is just shrinkage cracking from age. But if it's really bad, like I said, you're going to have to repair it. But this one's pretty good shape yet. Give the inside and outside a good clean with some glass cleaner, and then you can reassemble. So aligning this is a lot simpler than what I made it out to be. This is loose right now on top. So we want to go to the lower end of the band. Let's go this way. The tuning capacitor stops there, and then we move this. Now I did make a mark here. I don't know if you can see it. A little black mark. So right there is where my reference marks are, and I can just tighten this down. And if it's off a little bit, doesn't matter. During the alignment, that dial scale, see, it's off a little bit. That's the way it should spin. Got some damage here. Did I do that? Okay. Now I see I got the spring on the wrong side here. I'm going to move this spring over to here, and then I'm going to tighten this one up. Okay, we're back together. A few other changes I made. So I eliminated the 100 microfarad capacitor here that was reading way out of tolerance. I isolated this one, and I moved that capacitor here on the board. I drilled a couple holes, and I mounted the capacitor where it needed to be, bonded it to the board so it's there, and that capacitor replaces this capacitor. Okay, and there was also a 1200K resistor between the two of them to drop between this one and this one, and I relocated that resistor on the underside of the board between this connection and the pin 50. So the pin 50 now comes out after it goes through the capacitor, and the resistor comes out, and then it connects to this 1000 microfarad, and this purple wire goes off to the circuits. So that's all this, and then this capacitor here is another 1000, comes off this light gray wire and connects to that capacitor. So that's all. I'm retaining the 2000s, and I got rid of the 100. Next thing I need to do is this transistor heat. I'm going to add a heat sink to it. I'm going to get a small aluminum heat sink and mount it. All it was before was it was mounted on a stud, and I'm just going to add this in here just to keep that transistor cool. This might be a little too big. Let's see. Yeah, I might mount it like that, and then down to the stud. And I'll try and keep that transistor cool because it looks like it's been cooking here for a while. And I don't think the heat sinking was adequate for it. And to be honest, I think that screw was loose when I took this thing apart. So it wasn't really making any contact. It was just floating in the air, getting hot. So I'm going to make some nice cooling for it. And this is what that looks like. Make sure it's tight, give it a wiggle. If it's loose, just snug it down some more. Don't go too crazy with the torque. It's just a plastic body transistor. And then test for continuity between chassis and the collector and make sure you have no shorts. And then if there's no shorts, you're ready to go. But that'll keep that transistor nice and cool. Alright, so let's do our first initial power on test. Plug it in, turn on the power amplifier here. And we have no idea if this should work. I don't have an antenna right now, but it is working.
Lead in the best of 7 final with a 5-2 win last night in the Alberta capital. Mercedes driver George Russell will have the pole position for the second consecutive year at today's Canadian Grand Prix in Montreal.
Okay, so it's working. It's picking up stereo. It doesn't even have an antenna attached, and it's already picking up stereo signals. So we're in good position right here. So let's go through an alignment. Let's quickly go over this, and I'll show you what needs to be done. So the first step is they want us to ground pin 4 of this chip to prevent any signal from getting through. I'm not happy about grounding pins on chips, especially the output pin. What I could do is disconnect pin 4 and then ground it on the can, and that would prevent any signal from getting through. I think I might just do that instead. So what we do is we ground this point right here. This point's already at ground. No, this point's at power. So we ground this point here, and that prevents any signal from getting through here. And what we do first is we adjust this offset for 0. It's kind of like balancing the DC balance on a power amplifier. We want this to set to 0, and we set it with the 0 tuning meter, because the 0 tuning meter is connected to this amplifier. And if there's any DC offset here, it's going to show up in this meter. So what we want is to 0 this meter. That's our first step, and we're doing it here. Alright, so I lifted pin 4 of this chip, and then I grounded the connection that goes between pin 4 and the can. That's grounded, and then I'll be adjusting this potentiometer for our 0 offset. And we'll be using the 0 tuning meter as our adjustment. Let's see here, we're not too far off right now. Let me try adjusting that potentiometer and see how much it swings. We're pretty much bang on right now. Let me get a proper screwdriver here. Okay, so wow, there's really no adjustment there. Hang on. Not much of adjustment at all. It's pretty much maxed out. I wonder if there's a problem with those transistors. So I pull the transistors out and test them, and they are matched perfectly, and they have both have good gain, so they can go back in. But also I looked at these 2 resistors. These are the collector resistors on the circuit. Here and here. These are 6.8K. And these should be matched as well, and they're not. They're out of tolerance. Well, they're not that bad out of tolerance. They're like 6.2K, but they don't match. So I'm going to get a pair of resistors in here that match. Where are they? This one on both sides of this capacitor. This one and this one. I'm going to replace these 2. They're carbon comps. I passed them up from replacing them before because they were kind of close, but I'm going to make sure they're matched. Yeah, out of circuit, these 2 resistors are about 600 ohms difference between the 2 of them on 6.8K. That's a considerable amount. These two are matched within a tenth of a percent or less, and these two transistors go back in. So this should work after I replace these resistors. Alright, so new resistors are fitted. Let's go through and do that alignment one more time. Let's zoom in here so you can see the meter. And let's adjust and see what kind of range we get this time. Yeah, it's very not very much of a adjustment. So I think right about there is going to be center. That's where I'm going to leave it. I thought they would have a better, wider range of adjustment than that, but right there is going to be our center point. I'm going to leave it right there, and then that's what it's going to be. This 0 mark is going to be important for the next step of the alignment of the ratio detector. We're going to need to tweak the coil, and we need to get that center. So this is why I wanted to make sure this is 100% before we continue. So now that we got this zeroed on the amplifier, now we can zero the coil. So what we do is we tune the tuner to a station, to no station, just interstation noise, no signal, and then we zero the top slug with a plastic tuning tool. Okay, so I got it connected. Let's turn it on. I've got it here in the low end of the band. There's no stations. You can see our tuning meter is off quite a bit. So let's turn this noise down. And let's try tweaking this top slug. There we go. So we want to zero this as best we can. Right there I think is perfect. So the next step here is we feed in a signal, a strong signal, 90 megahertz, 400 hertz modulation, 100% modulation. Very strong signal, 1000 microvolts. We tune the signal for 0 on the tuning meter, and then we adjust the bottom slug of the ratio detector for minimum distortion. So I'll have to connect up a distortion meter to the output, and then we'll get this test or this adjustment going. Okay, signal's set up. Let's turn it on. Let's set it to our signal generator. So according to the tuning meter, we should be tuned right there. And let me set up the distortion analyzer, and we'll flip this on its side because the tuning lug is on the bottom. Okay, so I got this calibrated. Set it to read. And we are on the 1% scale, so this is 1%. So this would be 0.43% distortion. So let's see if we can tweak this to get it better. I have a feeling we will. Let me turn the slug. Oh, it's frozen. Break it. Oh, there we go. Broke it free. And I went right through the... Okay, so let's... Right there, looks not bad. So let's calibrate this again. Okay, we're still calibrated. Let's go down a range. 0.3% range. We are probably 0.15% or so. Let's see if we can tweak this. Tweak this better. No, not that way. Probably as good as we're going to get. And then not too far. Right there I think is... Alright, I'm going to leave it at that. Alright, so for the next step we reduce the RF signal level of the generator. We tune the Citation 15 to 90 megahertz. And then we start adjusting coils L105, L101, T102, T103 for maximum sensitivity and best symmetry on the sine wave output. But we have a problem here. They mention coils here, L105, that's our oscillator coil. L102 is a intermediate coil, and there is no T102 and there is no T103. But there is an L102 and L103. The only transformer here is T101, this one here, but they mistakenly call this T104. So I don't know, down here in the instructions, adjust T104 for best usable sensitivity. So there's a cock up here on the drawings and in the instructions. So we're just going to have to wing it. So they want us to do L105, L101. L101 is this one here, which is our antenna coil. We can trim that one. L105 is our oscillator coil. We can trim that one. L102 and L103 is these two, L102 and L103. We can adjust those as well. They call them T here, but they're not transformers. So we'll go through that, and everything is accessible from the bottom. And here's a diagram of the picture of the location. So L101's here, our antenna. First stage, second stage, L102, L103. Our local oscillators with L105. Our IF is called T101, not T104. So we could probably put T104 here. That is in the instructions, and then we have our trimmer capacitors. So let's start with that. I'll bring you back in. I'm not going to film any of this. I'm just going to turn it on. I'll make all the adjustments from here. And I'll still be using my blue adjustment tool. And we'll see if we can bring this in. One thing you need to realize is this is a quieting meter, not a signal strength meter. So it's opposite of what you're used to. Zeros on the right hand side here, and maximum 10s on the left. So watch when I increase the signal. I'm going to turn the signal up. Watch the needle. Okay, here we go. Going up in strength, and it gets closer to 10. Kind of maxes out there at 9, doesn't go any higher. But that's going to throw you off if you're using this as a guide. Okay, so I completed step 6. I went through and adjusted these 4 coils, and I kept adjusting the signal strength of the generator, keep going down in signal strength and keep adjusting these. And I'm also monitoring the harmonic distortion coming out of the tuner. So I adjust for best harmonic distortion, highest signal, most sensitivity, and least amount of noise. And just keep going through and doing that over and over again until you get it right. Now that was at 89 megahertz because I have a station right at 90.1, which is interfering, so I went down to 89 megahertz. So now next step is 7. I'm going to tune it to 106, and then we do adjustments on C128, C101, C106, C113. Same kind of thing. I go through and do this on the top end of the band. Now I do have a station at 106. Let me see here. That's 106. That's 107. That's 108. So I'm going to have to pick maybe even 105 has a station on it. So I'm going to have to pick a half megahertz frequency here, 106.5 maybe, and I'll do it there, and then we'll do these adjustments at 106.5. Okay, so I've gone through steps number 7, and I've adjusted these capacitors, these 4 capacitors, and pretty much peaked them to where they produces the best signal output, least distortion. This 128, that is your oscillator trimmer for the top end of the band. That one was way out, so I trimmed that in. And when you trim that in, you're going to have to go back down and trim this one in again, because this is the coil for the oscillator at the bottom end of the band. So between the two of these, you have to go back and forth a few times and trim these to get the dial scale to be 100% accurate. And then you move on to the other ones. Now, I did that, and then I went down and adjusted T104. Didn't make any difference on the adjustment. I think we're peaked out already. And then I did this step where you increase the signal strength quite large to a large volume, and then Oh, I didn't modulate it. I'll modulate 10 kilohertz, and then you optimize T104 for the lowest distortion. I did this at 400 hertz, not 10 kilohertz. So I'll redo this one, and then you go back and check on interstation noise where there's no station, and you make sure that your tuning meter is centered on 0. If it's not on 0, you go back and you repeat steps up here with adjusting that coil, step 5. Yeah, if this is off, you go back and do step 5, 4 and 5, and bring it back in. But I think I got it pretty close. It's pretty much bang on. You don't get much better than this. So I'm going to go through and do this 10 kilohertz one again, and then I'll jump down and we'll start doing the multiplex. Multiplex is working fine. I'm bringing in stereo signals on very weak stations, so I don't think there's going to be much adjustment here in the multiplex section. Okay, here's the noise, or the distortion adjustment, 10 kilohertz. I'm going to adjust T104, and right there is the lowest peak I can get. Oh, I lost my right there. Yeah, this is very finicky. I'm going to leave it right here. That's as low as I can get it. So moving on to the multiplex alignment, I can do some of these steps, but not all of them. I don't have a signal generator, stereo signal generator. So I can do the 19 kilohertz test pilot. I can do the 19 kilocycle traps, but I can't do the separation control. I don't expect I'll be making many adjustments here because this tuner is already working really well. I'm really impressed by how it's working at this point without even touching this part. It seems to be working very good on the stereo end of it. Now, I did notice that the frequency response this tuner is kind of bass heavy. It's kind of boomy. I don't know if that's by design or if that is because of the out of the multiplex we have these 2 transistors, and then we have this LC network here. This is a low pass filter network for taking out the 19 kilohertz pilot tone, I'm assuming. What is this? 407 and 408. Yeah, 407 and 408 are the 19 kilocycle traps. So adjusting these two kills the 19 kilohertz signal coming out, which you don't want that going through into your tweeters. But this here seems to be, I don't think it's flat. So I'm going to take some, I'm going to sweep some frequencies and do a frequency response test on the output of this tuner. I'll do that on the entire tuner. I'm going to feed the signal in from the antenna, and then I'll do a sweep on the frequencies, and I'll see how flat this is. If there's a huge problem with one channel or the other, I might dig into it, but if it looks pretty normal, I'll leave it alone. So there's the internal 19 kilohertz oscillator. You can see it's low by a couple hundred hertz. I'm going to adjust that, and I'll show you where the adjustment point is. Adjustment point's right here. This is R405, I believe, and this sets up the internal oscillator frequency here for this chip. So here we go. I'm going to go counterclockwise. Oh, it drops it. Okay, let's go clockwise. Raise it up a bit. Very touchy. There's our, okay, back it off some. This should actually be a 10-turn pot. It's so touchy. But I don't think it needs to be super bang on. It needs to be very close. Let's turn it down a little bit more. That's about as close as I can get it. 10 hertz out. 11. Yeah, it's very touchy. If I change that to a 10-turn pot, I could get it closer, but it is not happy to be adjusted at the way it is. So that's fairly close. Usually you want it within 100 hertz or so. It was locking in just fine before I touched it, so it's gonna lock in a lot easier now. Okay, so this is the output of the left channel, and I'm feeding it a fairly strong signal with 19 kilohertz modulated. Oh, there's even better. Let's turn this up. So we get a nice strong signal here. And that is the 19 kilohertz. Let's try adjusting this trap. I want to minimize that. Right there, I think. Okay, so let's turn this down a little bit. I don't want to go too far because it might affect the high frequencies, so let's leave it right there. And we're down in the noise, so that 19 kilohertz is gone. Let's do the other channel. There's the other channel. Adjust this one. Wrong way. Going down. Right about here. I'll leave it right there. Don't want to go too far with that. Okay, let's do a quick scan through the band. That's the weakest station on my band. This one's always in mono. This one's nice and quiet in the background. I was listening to it earlier. It's just silence in the background. That doesn't sound good. That's the music though. It is working really well, even on the weak stations. I don't know what that is.
I mean, you're hearing a stadium full of people do one more time, play that song.
Good. Nice stereo separation on this thing. Yeah, I'm really pleased with the performance of this thing. I know a lot of people don't even bother listening to FM, but there is a lot of good content on there lately, I've been noticing, especially where I live. Maybe it's time to check it out where you live. Maybe there's some good stuff.
And I don't know if it was on this radio station or another radio station, and that's okay. Like, you're now family and you can listen to other radio stations.
So I'm going by the center tuning here,
just
to center the station, and it's coming in pretty good.
Your presets? Oh, now my feelings are hurt. I heard another radio station last night.
Stereo is coming in really nice, so I like that.
Taste of Edmonton returns to Churchill Square July 17th to 27th. Indulge in the diverse culinary scene.
It's the top station there. Alright, so it seems to be working really well. So here's a look at the parts that went into this. All caps. All caps, you could have ran with these for a while. These are still working, but the problem with these caps is they all gained value. Like for example, a 500 microfarad cap would measure out about 800 microfarads. 100 would measure out about a 150 or 160. So they all went up about 50% or more in value. And yeah, that's from internal leakage. And so they needed to be replaced. There was very few caps in here that were still okay. They all have good ESR. These caps are big caps for 100 microfarad at 25 volts. They have very, very low ESR, but they're high in value now, which is way out of tolerance because of their internal leakage. And then we have this dead transistor we found in the early stages of the audio. This is open transistor. That's what caused our no audio at the beginning. And then all of these resistors were out of tolerance or getting very close to it, so I replaced a number of these. And these are very drifty with temperature as well. So drifty with temperature, both resistors and capacitors. So it's better if you get modern parts in for capacitors and resistors, and then they're more temperature stable. Well, there it is. I'm going to finish this one off here. I think we've spent enough time going over this tuner inside and out. It's a nice tuner. I really enjoy its performance. It's got some nice looks to it too. I like that, and it's a good performer. If this is something you're into, FM tuning, listening to this FM band, you probably want to have a really decent tuner, and this is one of them. So I'm going to leave it there. Thanks for watching. Take care, and we'll see you on the next one.